Okay, we're going to look at these sum and difference identities. This is given on your formula sheet, these four sum and difference identities. Let's look at the cosine ones first. It turns out that if the cosine of two angles subtracted is the product of the cosine of those two angles plus the product of the sine of those two angles. There was a really good teacher that had this shortcut up in his room. And when you're looking at cosine, just all you have to remember, you don't need the formula sheet because it's cos, sine, sine. And if it's negative, it switches to positive. So all you got to remember, if you're doing cosine, if you see sine, sine, and it's minus, then it must just be the cosine of the two angles added together. And if it's plus, it must be the cosine of the two angles subtracted. Now for sine, there's a structure here. You can see sine, cosine, sine. The sine of the difference of two angles is equal to the product of the sine of the cosine minus the product of the cosine of that angle and the sine. You kind of reverse it. So he had this great idea of just think sine, cosine, sine, and that'll work for sine. And it always stays the same. So if you're subtracting sine, cosine, and cosine, sine of these two angles, then it's just the difference of the sine of the angle. And if you're adding, it's just the sum of the sine of those angles. Well, let's look at some questions from the textbook. Here, I think it's page 95 of the textbook. It says the sine of 68, the cosine of 22, and then plus the cosine of 68 and the sine of 22. Well, that's sine, sine. I don't even need the formulas in front of you, but I can go down and find it. So it should just stay the same. So it should be equal to the sine of those two angles added up. So all you got to do, instead of writing all that out, it's just the sine of 68 plus 22, which is the sine of 90 degrees, which is 1. For the next one, you've got cos minus sine. Hey, that's cosine, but we're supposed to switch. So if it's negative, it means we add those cosine angles. So all of that is really just the cosine of 28 degrees plus 2. It's the cosine of 30 degrees, which is √3/2. And if they said without a calculator, you'd have to show a special triangle to show that you got that. Okay, the next question, 2.3 on page 195, is a little bit harder because you've got to change 108 degrees into the cosine of 72. You've got to find that reference angle and know with all stations to Cape Town that it's negative 72. Cosine of 108, 8 degrees past 180, you have to know that it's cosine of 8 degrees, and cosine's negative in that third quadrant, so it's negative there. The cosine of 252, it's 72 degrees short of 360 in the fourth quadrant. Sine's negative there. But hey, we've got our nice structure now. We had all these weird numbers up there. Now we got 72.8, 72.8. The two negatives make a plus here. This negative makes this plus a negative here. So it's cos minus sine. We're supposed to add that 72 and 8. That's what the cosine rule says. When we have cos minus sine, we're supposed to add them. So it must be the cosine of 80 degrees. Well, that's the main thing. That's how you do it. Those are sort of three examples. That should help you to kind of get started. I've got another example here. Maybe we'll, other examples of just doing the same things all the way to 2.8. And then there's another, I think I'll make another video where we show how we could work out something like the cosine of 15 degrees. We didn't have a calculator. We could still do it by getting a little bit clever. So anyways, hopefully this video will help. Okay.